Hello everyone. I'll start my presentation. The title is Risk-Responsive Frontal Neuron Spread Inquired Salience. This paper is published in Neuron this year, January. This paper is from the John Baum's lab, and his research interested in neural circuits mediating associative learning and decision making and its related brain region and behaviors. So this paper is related with risk-based decision making. It is a decision among options of which probabilities of outcomes vary. So the occipitotal cortex has been thought to be involved with decision making. For example, this paper says that occipitotal cortex neuron firing is related with outcome anticipation, and this paper says that occipitotal cortex neuron firing is related with the outcomes probability. So the outcomes uncertainty, we can express it as variance of outcomes. For example, in this case, in case of binomial distribution, if each option's probability is like this, 0, 33, and 67, and 100, then uncertainty of each options become respectively like this. And so you can see that this and this same, and this and this same. So if the firing of OFC neurons follows just uncertainty, then the firing at 0% and 100% should be same, and the firing at 33% and 67% should be same. To test this, the authors trained rats and recorded the firing of OFC neurons. In the trial initiation, the house light was illuminated and mouse responded with nose pucking, and the 4 orders associated with the 4 probability was delivered to rat, and the rat exited the port and responded to where, and 1 second after, sucrose fluid is delivered to the rat according to the probability, and the house light was switched off. Average latency from order offset to responding at fluid well, or average number of leads during anticipation period of 100% and 0%, significantly different from both of 67% and 33%. So this is the recording site in the retrooccipital cortex and alveolar insular cortex, and this is firing of a neuron in the trials, and this is mean firing rate of neurons shown in D during real anticipation period. So 53 neurons firing more in 33% and 67%, and 67 neurons firing more in 0% and 100%. And this is the average firing rate during the outcome anticipation period. So the authors analyzed this with activity index. Activity index calculated this. So in this case, positive activity index means that the neuron fired more in 100% than 0%. So in this case, similarly, positive activity index means that the neuron fired more in 0% than 100%. So the firing tendency is biased to more in 100%, And in this case, the firing tendency is biased to firing more in 0%. So the firing at 0% and 100% was different. Similarly, in this case, positive activity index means that the neuron fired more in 33%, and in this case, the positive activity index means that the neuron fired more in 67%. And the firing tendency here is biased to firing more in 33%, and the firing tendency is not significantly biased in this case, but it is likely to be because of already low firing rate. So anyway, the firing at 33% and 67% was different, and the firing of all-efficient neurons then did not follow only uncertainty. Then one possibility is that these neurons may track the acquired salience associated with both certain and uncertain reward. Salience is the ability to attract attention standing out relative to its neighbors. And acquired salience is the salience of the cue that acquired through conditioning experiences. There are two different views for acquired salience, and one is the view of McIntosh. He said that the acquired salience of a cue increases as its associative strength with certain outcome increases. For example, in this case, if a heron she ripples with fish repeatedly, and the heron was reared repeatedly, then the associative strength between CS and US increases, and the acquired salience of CS increases. And the other view is say that acquired salience of a cue increases as its associative strength with uncertain no outcome increases. For example, after previous example, at some time, the hero she ripples without fish and non-rearded. Then the associative strength CS and no US also increases, and the acquired salience of CS increases. And he, Silverall, reconciled the two views, and he said that acquired salience is determined by both CS-US association and CS-no-US association. So he proposed a model of acquired salience like this, but we don't know F and W, so the authors of this paper applied the linear regression approach to the data. Linear regression analysis determines how well the proposed linear regression model consists of linear sum of independent variables fit with the observed data. So they proposed two linear regression models, and one contains acquired salience like this, and in each 0%, 33%, 67%, and 100% trials, YI means that firing rate of 1 over 282 neurons in ith trial during anticipation, and X1I means latency from order offset to unpoke from the order port in ith trial, and X2I means latency from order unpoke to well entry in ith trial, and X3 means number of leaks during the outcome anticipation in ith trial. So X1 and X3 and X1 and X2 and X3 and CS-US association and CS-no-US association is an independent variable or regressor. And gamma 0 to gamma 5 is the coefficient of each regressor in the model. Similarly, the other model contains the uncertainty component, and in this case, beta 0 to beta 5 means the coefficient of each regressor in this model. For 0% and 33% and 67% and 100%, they assume that CS-US association like this and CS-no-US association become like this, and variance become this. So, and the coefficient of each regressor was determined by MATLAB linear model fit function. And finally, the two regression model was established. How well-proposed linear regression model explain the observed data can be estimated by coefficient of determinant. High coefficient of determinant means the model well explains the data, and it can be calculated as this. So the coefficient of determinant of the acquired salience model was product of the coefficient of the consultant model, and this from this coefficient of acquired salience model was significantly larger than coefficient of uncertainty model. So we can say that the acquired salience more explain the firing than the uncertainty. And further, the coefficient of CS-No-US association tended to be larger than that of CS-US association, and CS-No-US then contribute to more than CS-US association in acquired salience. So we can think that partial reward which contains CS-No-US component cause larger acquired salience than consistent reward which only contains CS-US association. So they applied their model to previous researches. In ONS and culture research, the animal presented 0.27 amount of reward or 0.33 amount of reward, and or in this case, the animal presented with 0.18 amount of reward or 0.42 amount of reward. And then this case is similar with the case of partial reward, and this case is similar with case of consistent reward. So the acquired salience of this case is more than this. And in Hyo-Pil's research, a rat is presented with order mixture, and if a rat shows the direction associated with larger proportion, then that the rat was rewarded. The rat could encode the mixture in the three ways, like this, and like this. So this is similar with partial reward situation. Then this mostly contributes in the acquired salience of both correct and incorrect choices. So in the case of this is more confused than in the case of this. So this situation would be more in this than this. And so this mainly contributes in acquired salience of both incorrect and correct situation. So the acquired salience gap between correct and incorrect was smaller in here than here. And in the case of this, acquired salience in correct trials was explained mainly by this, and in incorrect trials was explained mainly by this. So the acquired salience was bigger in incorrect trials. Okay, before discussion, do you have any question? Okay. Do you agree with the model of acquired salience?
So this paper compared two models, acquired salience and uncertainty, to models. Could you explain again the difference, the meaning of two different models?
This model contains acquired salience, and this is coefficient neurons firing function, is the model contains uncertainty component. So the author say that this model more explained well than this model.
What is variance? Variance?
Yeah.
Not the equation. Just explain. Could you explain about the examples or some concepts? You
Model of concept.
yeah. I mean, every model try to explain some phenomena, right? So could you explain what they want to explain by that model?
What they want to explain the model.
What they want to explain, what kinds of phenomena they want to
OFC neuron spiraling. Spike rate.
Just before show this paper, this picture, right?
Yeah.
And since wanna hear that what is this
So this explain about
since want that.
no. This explain about acquired salience. So that's quite clear to me. However, I want to know the compare between uncertainty and acquired salience. So I understand now. I understand acquired salience. However, why they want to compare?
Why?
Why? So before the uncertainty model, they tried
Uncertainty is defined as the variance of outcomes. And if the neuronal firing just follow uncertainty, then in this case and this case should be same. Same neuronal firing and same neuronal firing. Should be. But you can see the neuronal firing pattern different in 0 and 100%, and here the firing at 33% and 67% also different. So you can say that the firing of the OFC neuron did not follow just the uncertainty. So we propose another component that can explain the neuronal firing.
So this is the next question. In this area, do you know how many groups or how many people really? So I mean, how well accepted this model? So because this model say the fire rate between 0% and 100% should be same. That means they want to, that is kind of prediction, right? So their prediction should to me the 0% and 1% of reward should be different. In my knowledge, because that is kind of reward. So they are firing if they are OFC involved with some reward, then that should be different. But they, in this model, they said it should be same. So why this model?
Just we define the concept of uncertainty as the variance, and Do you have any question?
So, well, in our paper, how was the acquired savings was measured?
Actually, they did not show how exactly they calculate the required salience, but maybe similar. They calculate this similar with this paper.
Could you quote the calculation of CAC loneliness?
Required salience.
This not back. Oh, when the variance was no.
Where?
You just heard 67% and 33% shows the one variance and
Here?
what is the meaning of the variance? They input the 0 to 1 and 100%, but in 33 and 67% input 1 point. That's the meaning.
Here, it's variance of 0% and 100% 0
What is the meaning?
variance.
Yes.
Statistically, in binomial distribution, the variance can be calculated NPQ. do you know this? Yeah. So 0% is P, then Q is 1, and N is a trial number, so the NPQ is 0. And 100% also NPQ is 0.
Yes.
And in this case, the variance is same, and they just put in 1 because the coefficient of variance can be fit the exact variance.
In the beginning, you said that they, according to the uncertainty concept, 0% and 100% of reward and 33 and 67% of reward would cause similar pattern of firing, right? In the beginning.
If they follow uncertainty, then should be.
Right. Could you explain more about the uncertainty? Because I thought if there is 33% and 67% of chance of getting the reward, then that should cause different.
0% no reward, then the reward is certain, okay? 100% reward, then the reward is certain also. And then the uncertainty can be defined as variance. So the variance of 2 is the same.
But what about 33%?
So in this case also, they just defined uncertainty as variance. So in these two cases, the variance calculated as same.
So regardless of how much percent there is for the reward, it just, so, doesn't matter how many percent there is of giving the reward, they just, like, thought that that is the uncertainty.
Some reason is thinking that 33% is 33% positive reward and 67% is 67% reward. So there's a difference between the amount of the reward given, the probability of the reward given. So 67% could be considered more positive thing.
So wouldn't that cause difference in the pattern of firing? Like, why would they think that those two would cause the same pattern of firing?
Did not cause just then if just follow uncertainty, then the firing pattern should be same. But in real situation, they did not follow this variance. So in real situation, the neuronal firing of this and this is different.
So I'm asking, like, following the uncertainty concept?
No.
No, when they were thinking that uncertainty concept was correct, like, why did they think that?
In previous experience showed that 0% and 100% firing, and we can see that here 53 neurons shows the firing significantly more in 33% and 67%, and here then 100% and 0%. And these two values show different variance, and so uncertainty also contribute the neuronal firing.
When they explain the acquired salience, they say that if the reward is given probabilistic, then the CSUS and CS-no-US has different associative strength, and they said CSUS is have more associative strength than CS-no-US. So if that is the probabilistic, how can you be sure what is more firstly associated with CS?
Sorry.
Come on.
One more time.
When the association is made, CSUS and CS-no-US, how can you be sure CSUS association is made before CS-no-US association?
Before no-US association.
Then the reward was given probabilistic like this 33%, 67%. Then the CS, like Q, it can be associated with no reward first.
No.
It can be.
So they just assume that the reward is associated first before
Yes.
no-US. So
Association should be first made by CS-US first.
Are you sure they should? At first time, there should be CS-US association. Then there can be no reward.
Yeah.
In this experiment,
They did not show in trial what percent is first three shows, but I think that
you think that
yeah, they did not what property is first shown in the experiment, but I read their view of equal salience, and they say that should be CS-US association first should be firstly established, and then CS-US association can be established.
If there is a millions times of repetition of their association, they can. I think that it can be. They can know that probability, but I don't do this kind of experiment. I cannot sure. But
in this experiment, they are saturated to this kind of path for a very long time. So I don't think it's very important to show this in the first place. They are already saturated. So I think one problem of this model is that in this model, the lower the percentage of probability of reward, the salience goes bigger and bigger, right?
I cannot hear.
33% salience is bigger than 67%, right?
Yeah.
And the lower the probability of reward, the higher the salience is, right?
Yeah.
And so it approaches, when the probability goes down and down, the salience should go up and up, right?
Before 0.
Yeah, before
Yeah.
0. But when they go to 0, it goes to 0. The salience goes to 0.
Actually, they did not think about that.
But in this mathematical
Yeah.
modeling, that's what happens, right? If the W weighting coefficient is that's what we can expect from this model. Right?
I think that at some time, equal salience become maximum value, and then actually they just assume the association value like this, but the association can be calculated, complicated equation, and they did not show that.
So what I think is that maybe when the probability of reward goes down to maybe 5%, 3% like that, some other factors that we consider this model is reasonable, and I don't think actually the firing pattern of 3% reward probability is that much different from 0%.
We do not know.
Yeah, we do not know,
I
but
think to test that,
yeah,
they
they should have done that kind of thing and see if that really approaches with a very small amount of your probability how your firing pattern.
I don't think about that. The model is not perfect, so should be modified, I think.
What kind of other behavioral phenotypes also involved in orbital cortex?
They think that these patterns also can be contribute the firing patterns, like latency from order offset to unfold from the order port, or latency from order unfold to word entry, or number of leaks during the outcome anticipation.
So the smelling, leaking behavior also.
They can. They think that this component can contribute the neuronal firing.
So what kind of cell types or cell populations are most likely in orbital cortex?
They did not show cell types, just they inflate the bundle on the here this web type-specific activation.
I just wonder that if they specify the cell types, that their first hypothesis might be correct, but they checked the whole population.
I think this method cannot distinguish the cell.
Yeah.
I wonder, I have two questions. Which reasons are connected to orbital frontal cortex? And that's the first question. And second question is, in figure 1, they consistently use man-Whitney U-test. Explain about this.
Sorry, actually, I did not know exactly what we tested.
Do you know why they use this test? Why they use this
Where
man-Whitney?
where they use.
And in figure 1,
Here?
they use that man-Whitney U-test in figure 1B and C.
And see, they calculate the p-value and show that the average latest from order of set responding at the fluid well is significantly high in 0 than rest. And they also show that this average number of leads is significantly low in here.
Yes, but every single statistical test have their own meaning. So I haven't seen this test before. So I wonder what kind of meaning do this test have. That's why I want to know. If you don't know,
I don't know exactly.
so what's the connection and
OFC is interconnected with the PLA, lateral and interline, ventral hippocampus or ventral striatum.
Last striatum,
Ventral striatum.
interstriatum.
And also, I saw that OFC is also connected with dorsal striatum.
just trying to could be some interaction between the reward and predictions.
Yeah.
Is there any research that if they cut it off or lesion the amygdala, and they get more risky selection?
Yeah.
Is there any research like that?
Yeah, many research say that, for example, if they lesion PLA and then the red cannot discrimination the risk, and so there are many users.
I think this figure C, the tendency seems to be quite similar with the pattern of the acquired aliens.
Yeah.
So would it reflect the acquired aliens? Actually, the previous question I gave to you was about not the calculation of the acquired aliens, but behavioral measurement of acquired aliens. The previous question I gave to you was not the calculation of the acquired aliens, but the behavioral. What is the behavioral outcome of acquired aliens? So, and might that behavioral tendency reflect the acquired aliens?
Yeah.
Is first question, and in the model that they use, the regression they said the variables are independent. Is that what they said? Maybe it's not that important, but maybe this CS-US and CS-US associative strength is not that independent.
Yeah, and they did not show figure, but when they exclude the three, also they find the same result when they exclude the three. So, yeah.
So, and the number of leaks during the outcome anticipation, that variable can be also dependent on the other variables.
It's possible.
Yeah, so I just wonder whether in the linear regression analysis, the variable dependency, the dependency of variables to each other, how would that dependency be important?
Yes. Actually, mathematically it should be independent, but they assume that the five regressors did not. They assume that five regressors independent, and when they exclude the three regressor, just only two regressor model also explains where the neural firing. So if don't you have any question? Okay.
This paper uses so many mathematical calculations, so it's not easily obtainable. Could you explain the meaning of this paper with your own?
At previous researches, people say that neuronal firing of OFC is related with uncertainty, but they define the uncertainty as a variance and show that the neuronal firing of OFC is not just related, just on uncertainty, and they use the concept of acquired salience, and then they shows mathematically how the acquired salience is related with the neuronal firing, and they show that finally the acquired salience model is more explained of firing than uncertainty model. So this is main conclusion of them.
Is this the first paper to show the neuronal pattern, firing pattern following the acquired salience model? Is there any other paper that shows the neuronal firing pattern that follows the acquired salience?
What did you mean? What paper? This?
Not WebC. This paper showed that WebC neurons firing follows the acquired salience model. So is there any other paper, any other population of neurons?
That was it.
Yeah, not WebC, but other population of neurons that reflect the acquired salience.
I cannot see other paper.
So if this is one of the first papers
Yeah.
that should be some, have that importance in
Yeah.
I'm just curious about the region. So they are also recording the A-brain cortex. So you think, wouldn't the subpopulation in this A-brain cortex and the lateral orbital cortex be different? just cover all of that region.
Region here,
Yes.
OFC contains the lateral, the cortex and neuroinsular cortex. So
If you go more posterior, does it disappear?
I don't know.
If you go, I think so. If you go more deeper in posterior,
Yeah.
then you can't find the orbitofrontal cortex, only the anterior part, right?
Yeah. Yeah.
Because if you go more to the posterior,
Yeah.
that part will be the striatum part,
Yeah.
and A granulosa part will be still there.
What about mouse? To mouse, is there any papers that do similar experiment, behavior experiment with the mouse?
Yeah.
Okay.
Similar experiments also can be mouse also have OFC and similar, did not similar, but the paper also show that mouse OFC is also related with risk.
How they do that? They do lesion or recording?
Region,
Lesion?
region and the behavior test or like teammates test or
Teammates? Totally different behavior program. This.
yeah, different behavior, but the task was related with risk.
Related to Softa's question, this recording site is different among the animals. So did they mention some maybe did they analyze that if there is a difference between among the animals, because recording site is different. So like in number 3 animal, the recording site is actually they mentioned that it's not orbitofrontal cortex, but different region. And so is it also orbitofrontal? Any granular? Is it also included
Yeah.
as orbitofrontal?
I think in human study there are some studies that are concerning anterior cingulate cortex and risk related decision making or prediction and reversion. Do you know any connection between those two regions? Any studies that are concerning those two regions together?
Connection between ACC and OFC is not, I think, I cannot see the study of them, but ACC also connected with BLA and OFC also connected with BLA